The Voyager spacecraft, beloved by space enthusiasts, have returned to the spotlight with recent developments. In late 2023, it seemed like we might lose communication with Voyager 1 forever. On December 12, 2023, NASA reported that Voyager 1's flight data system, consisting of 3 onboard computers, began transmitting binary gibberish back to Earth. This repeating pattern of ones and zeros baffled engineers. Although the spacecraft remained functional and could still receive commands, something was clearly wrong. NASA initially attempted to reboot the system, but that proved ineffective, as the spacecraft continued sending nonsensical data. After weeks of troubleshooting and employing every possible strategy, NASA engineers finally devised a solution. But before diving into the fix, let's take a closer look at the remarkable Voyager 1 spacecraft and its extraordinary legacy. The legacy of Voyager 1 and 2. It is incredible that both Voyager 1 and Voyager 2 have been operational for nearly 47 years. NASA has worked tirelessly to maintain these spacecraft, not only to gather as much data as possible about interstellar space, but also in the hope of celebrating their 50th anniversary in space. Voyager 2 launched first, on August 20, 1977, followed by Voyager 1 on September 5, 1977, making them the oldest active spacecraft. What's astonishing is that these probes were only designed to last 4 years. Over their extended missions, they have achieved numerous groundbreaking discoveries. Voyager 1 revealed that Jupiter's moon Io was not just a barren rock but a volcanically active world. Its captured image of an Io volcano erupting into space stunned scientists and redefined our understanding of the moon. Voyager 1 also delivered awe-inspiring images of Saturn and discovered that its largest moon, Titan, might have liquid water on its surface. The recent issue with Voyager 1. The communication problem stemmed from a malfunction in Voyager 1's flight data system, a crucial component enabling the spacecraft to operate autonomously on its deep space journey. At a staggering distance of 15.5 billion miles from Earth, the ability to communicate with Voyager 1 is an extraordinary technological feat. The flight data system comprises various parts, including a central computer, data storage units, command interfaces, and telemetry systems. Voyager 1's primary computer, the Command and Data Subsystem (CDS), processes commands from Earth and manages the spacecraft's functions. By modern standards, this computer is incredibly primitive, boasting just 68 kilobytes of memory and a processing speed of 88 kHz, equivalent to around 8,000 instructions per second. In contrast, today's processors operate at speeds of billions of instructions per second, and even smartphones have memory measured in gigabytes. NASA engineers discovered that approximately 3% of the flight data system's memory had become corrupted, likely due to cosmic radiation or the effects of time. Since the faulty chip could not be repaired, the team devised an ingenious workaround. They redistributed the corrupted code into unused portions of the memory. Implementing the fix. The first patch was transmitted to Voyager 1 on April 18, 2024. Given the vast distance between Earth and the spacecraft, it took nearly 2 days for NASA to receive a response. On April 20, 2024, the team received confirmation that the fix had worked, much to their relief. Engineers now face the task of rewriting the remaining corrupted code to restore Voyager 1's ability to transmit critical scientific data. Challenges over the years. This is not the first time the Voyagers have encountered issues. The harsh conditions of deep space have taken a toll on both spacecraft. Communication with Voyager 2 was briefly lost in August 2023, and engineers feared it might be the end. However, contact was unexpectedly re-established days later. To conserve power, NASA has gradually deactivated non-essential systems. Voyager 1 now operates with just 4 of its original 10 instruments, while Voyager 2 has 5 still functional. Despite these limitations, the Voyagers continue to make significant contributions. For example, in 2015, Voyager 1 discovered that solar winds could still influence magnetic fields beyond the heliopause, the boundary marking the edge of the Sun's influence. Remaining instruments and contributions. Both spacecraft continue to use their magnetometers to measure magnetic fields, providing invaluable data about interstellar space. Additionally, their low-energy charged particle instruments remain operational, offering insights into the behavior of charged particles. These instruments were instrumental in identifying the heliosphere in 1993. To conserve energy, NASA has also deactivated onboard heaters, relying on hydrazine thrusters to keep the spacecraft warm and operational. The Voyager's remaining instruments include micrometeorite shields and optical calibration targets, which ensure the accuracy of their particle measurements. As the Voyager's journey farther into interstellar space, their discoveries continue to expand our understanding of the universe, proving that even aging technology can yield groundbreaking insights. The Voyager spacecraft, designed to communicate scientific data gathered by their instruments, have faced challenges due to their aging systems. One such instance occurred when Voyager 1 experienced a malfunction in its flight data system. NASA engineers, confronted with this perplexing issue, devised an innovative solution by reallocating corrupted data within the system's memory. This temporary fix restored the probe's ability to transmit scientific data to Earth, marking a significant achievement in its ongoing mission. Over the years, both Voyager 1 and Voyager 2 have made groundbreaking discoveries, reshaping our understanding of the solar system and beyond. Voyager 2 provided humanity with its first close-up views of Uranus and Neptune, capturing stunning images and collecting valuable data about these distant giants. Voyager 1's encounters with Jupiter and Saturn revealed breathtaking images of their moons and rings, uncovering geologically active worlds and complex atmospheric dynamics. Beyond their scientific contributions, the Voyagers carry a symbolic message from humanity to potential extraterrestrial civilizations. Each spacecraft is equipped with a golden record, a meticulously curated collection of sounds, images, and music representing the diversity and richness of life on Earth. Created under the guidance of renowned astronomer Carl Sagan, these records serve as tokens of goodwill and invitations for communication with beings beyond our solar system. The golden records contain natural sounds like bird songs and ocean waves, greetings in 55 languages, and a diverse selection of music spanning classical and contemporary genres. Encased in durable, gold-plated copper shells, each record also includes instructions on constructing a playback device, should they be discovered by an extraterrestrial civilization. While primarily intended to convey Earth's culture and existence, these records also act as time capsules of humanity's aspirations and achievements. The visual content on the records portrays various aspects of life on Earth, including landscapes, animals, human anatomy, and scientific diagrams, offering a snapshot of our planet's biodiversity, geological diversity, and technological advancements at the time of launch. The longevity and resilience of the Voyager spacecraft have been made possible by strategic power management and the dedication of mission engineers and scientists. As the probes continue their journey through interstellar space, they rely on a diminishing power supply from their radioisotope thermoelectric generators, RTGs. These generators convert heat from the natural decay of plutonium-238 into electricity, enabling the Voyagers to operate far beyond their original mission timelines. Maintaining communication with the Voyagers presents unique challenges due to their immense distance from Earth. Despite traveling at speeds exceeding 35,000 miles per hour, the spacecraft are gradually moving farther from our planet. However, Earth's orbit occasionally brings it closer to the probes, creating windows of opportunity for more efficient communication. During these periods, commands are sent, data is received, and the spacecraft's operations are maintained. The Voyager's scientific instruments, marvels of engineering, were designed to endure the harsh conditions of space and function reliably over extended periods. While some instruments have been deactivated to conserve power, others, such as magnetometers, remain active. These instruments continue to provide valuable data on interstellar space dynamics and the interactions between solar wind and cosmic particles. A notable discovery occurred in 2015 when Voyager 1 confirmed the presence of cosmic rays beyond the heliopause, the boundary marking the edge of the solar system's influence. This finding underscored the spacecraft's role as humanity's ambassadors to the cosmos, continuing to explore and transmit data that expands our understanding of the universe's vastness and complexity. Looking ahead, The Voyager's futures remain uncertain as their power sources continue to decline. Eventually, their instruments will cease functioning, and communication with Earth will be lost. Despite this inevitability, the Voyager's legacy endures as enduring testaments to human curiosity, exploration, and the unyielding spirit of discovery. The Voyager spacecraft represent a pinnacle of human achievement in space exploration. From their humble beginnings as missions to study the outer planets to their current roles as pioneers of interstellar space, these spacecraft have defied expectations and pushed the boundaries of scientific knowledge. As they venture further into the universe, their discoveries inspire generations and remind us of the boundless wonder and vastness of the cosmos we inhabit. Instruments on the tests are exchanged. Often some have been off for a really long time. Presently to ration power beside the instruments are the test's radioisotope thermoelectric generators. These generators use plutonium-238 to control the specialty and keep them warm and have permitted the tests to expand their missions for so long anyway. They are beginning to become more fragile and more vulnerable and one day will quit working. Out and out finishing the Void Explorer missions perpetually, and that day could come extremely soon. However, in light of the fact that the tests will one day go quiet, that doesn't mean that the Explorer missions will be futile to us. We should not fail to remember that both shuttle convey a message from Earth for other high-level human advancements that may be out there, and assuming they possibly spot these tests in space. The Explorer brilliant records are phonograph records that were put on board both of the Explorer rocket. These records were planned to give a preview of Earth and its occupants for any extraterrestrial insight that could experience the tests in the far-off future. The records incorporate accounts of different regular sounds from Earth, for example, thunderbird tunes. What's more, the sound of sea waves. They too contain good tidings communicated in 55 dialects. What's more, melodic determinations from various societies all over the planet. A portion of the music pieces incorporate Bach's Brandenburg Curto No. 2 Beethoven Ensemble No. 5 and In All Honesty Throw Barry's Johnny Be Great. The records too contain 116 pictures encoded in simple structure portraying different parts of life on Earth, including scenes, creatures, human life structures and logical outlines. It's positively worth focusing on that the content was organized by a board led by the late incredible Carl Schon, the stargazer, cosmologist and science communicator. The records are made of gold-plated copper and are intended to endure the afflictions of room travel for billions of years. Each record is encased in an aluminum cover with guidelines for playback engraved outwardly, remembering data for how to fabricate a pointer and a cartridge to play the records, as well as a chart showing the area of the Sun comparative with 14 pulsars, which can be utilized to decide the overall setting of beginning of the rocket. Yes, assuming there are unfriendly outsiders out there, we just gave them bearings to our planet. They could not care. The basic role of the brilliant records is to pass on a message of altruism from humankind to any extra earthly creatures that could catch the Explorer tests. Very much hopefully that doesn't occur at any point in the near future. Presently recall at the point when we let you know that we had something incredible to let you know it needs to do with the astounding reality that we're still ready to speak with the tests at all, with them both being more than 15 billion mil away. Explorer 1 is creating some distance from us at around 38,000 mph, and Explorer 2 is moving at around 35,000 miles per hour. Yet, here's something intriguing that you likely didn't be aware. For a piece of consistently, the Earth comes around the Sun and is moving towards both shuttle quicker than they're moving away. That is correct. Earth in its circle swings towards the space apparatus at a speed of 67,000 miles per hour. Subsequently, their distances to Earth are drawing nearer for a brief time. They never change their outward movement. Us and the Earth change both. Of the Explorer tests proceed their mission to investigate interstellar space. What's more, communicate significant logical information back to Earth. They stay the farthest human-made objects from Earth, working past the impact of our sun-oriented breeze in the interstellar medium. They are really a demonstration of the creativity of the human creative mind. The explorers celebrated for their strength. What's more, continuous investigation of the universe. Address a victory of human inventiveness. What's more, tirelessness. The rocket Explorer 1 and Explorer 2 sent off in 1977 as part of NASA's aggressive mission to study the external planets and afterward adventure into interstellar space have surpassed all assumptions almost 50 years after the fact. They keep on sending back important information, pushing the limits of our comprehension of the universe. Explorer 1, the uttermost of the two, has reached an astounding distance of 15.5 billion miles from Earth, while Explorer 2 paths intently behind, both impelled by radioisotope thermoelectric generators, energized by plutonium-238. These generators, which have kept the tests warm and controlled their instruments for a really long time, are a confirmation to the high-level designing that went into their plan, notwithstanding their age and the unforgiving states of room both explorers have endured through various difficulties lately. Keeping in touch with them has become progressively testing as their frameworks age and their power sources debilitate. Designers and researchers at NASA have needed to go with hard decisions about which frameworks to close down and how best to moderate V power for basic instruments like the high increase receiving wires, which are imperative for keeping up with correspondence over immense distances. One of the most momentous parts of the Explorers is their locally available innovation, which by current norms is inconceivably crude yet astoundingly strong. Explorer 1's order and information subsystem albums, with its simple 68 kilobytes of memory and handling rate of 88 kers, pales in correlation with the present high-level figuring frameworks. Notwithstanding these restrictions, the albums keeps on dealing with the space apparatus capabilities, process orders from Earth